Okay, you guys, we're back for our fourth video now being uploaded. Son of a gun, just having fun with logs, right? Well,
right.
Okay, there was homework number 40 up there. Page 476, written exercise 33 to 41 all, and 45 to 51. Okay, here's a few of the problems from that I'm gonna work out, and then we'll get to the new stuff. The new stuff isn't that long or very difficult stuff. I think you'll be happy with the new stuff. The new stuff, in fact, the new stuff involves using a calculator. So you will need to have a scientific calculator with you that'll do logs on it, or your smartphone will most likely do logs as well if you have a smartphone. So, but you will need to have some kind of a calculator. So you might want to pause the video and get yourself a calculator. We'll be using it for the second part, the lesson part of this, not for the first part where I'm going to be actually working out problems from last night's homework. But you will need a calculator for the second part of this. Okay, here goes. Okay, here's 36 from last night's homework. Okay, so first thing I'm going to do is pump this 2/3 up as the exponent there, and I'm going to get log base b of x squared plus 7 equals log base b of 64 to the 2/3 power. Now, 64 to the 2/3 power simplifies. Okay, what is it? I'm not sure off the top of my head, but I can figure it out. It's going to be log base b of, okay, cube root of 64, which is 4. 4 squared is 16. It's log base b of 16. I just turned 64 to the 2/3 into 16. Okay, so now I've got them logs on both sides, right? So drop the logs. What do I get? X squared plus 7 equals 16, right? So I minus 16 from both sides, I get x squared minus 9 equals 0. Oh my gosh, it's a dog. Difference is squared, so it's, actually, I could do it as x plus 3x minus 3 like that, or I'll solve this one this way. Look, you could add 9 to both sides. X squared equals 9, right? Then you could actually solve it by square rooting both sides. Don't forget, plus or minus, x is plus or minus 3. So that's positive and negative 3, which are my solutionalis potentialis, my potential solutions. I don't know if they both work. I got to try positive 3 and negative 3. Let's start with positive 3. 3 squared is 9 plus 7 is 16, right? That doesn't even have a variable, so that's positive. So good. But look, negative 3 squared is also 9 plus 7 is also 16. So they are both good answers. So there you go. Positive and negative 3. They're both good solutions. Okay. How about this guy? Okay, look, there's a subtraction, so I'm going to make that log of division. I'm going to squeeze them together. I'm going to get log base a of x over x minus 5 equals log base a of 6, right? Oh my gosh, I squeezed them together. Now, drop the logs and you get x minus 5 equals 6. Okay, ooh, yuck, x minus 5 downstairs, bad, bad. Guess what I do? Multiply and make it go away. But if I times this side by x minus 5 to cancel that, I have to also times this side by x minus 5. Now I get x equals 6x minus 30. If I distribute that 6, now let's see what happens. Move this guy over. X minus 6x, that's 1x minus 6x is minus 5x is negative 30. To get rid of times negative 5, I would divide by negative 5. And I get x is negative divided by negative is positive 6, which is my potential solution. Look, 6, that's good. 6 take away 5 is 1. Ooh, barely, but it's okay. It's still positive. And 6 is obviously positive, so guess what? Good solution. Okay, now over here. Oh my gosh, this is the kind that has log only on one side. Look, log here, not over here. What should I do? What should I do? I'm not too sure what to do. Oh, I don't have it up there. Never mind. I thought I had it ready to go. Never mind. What do I do? Convert or eat dirt. Let's convert. So here we go. We're going to go 2 to the 4th power equals x squared minus 9. That's just straight up converting. This base to this power equals that. Okay. This is 16. 2 to the 4th is 16 is x squared minus 9. Add 9 to both sides. 25 is x squared. Remember, square root both sides. Don't forget, plus or minus 5 is x. So positive 5 and negative 5 are my potential solutions. Let's see, yeah, just like on this one, or wherever we had it, just like over there, it's negative 5 squared is going to be 25 minus 9 is good. Positive 5 squared is 25 minus 9. They're both good solutions. So x is positive and negative 5. Okay. This number 41 is just like the last problem that I showed you from the last video. It's a function thing. So f of x is log base 2 of x. G of x is 4 to the x power. So let's find composition of functions. F of g of 3. We did that before. So what do? You start on the inside and you say, what is g of 3? G of 3 means you go to the function g, wherever you see an x, and you replace it with 3. So it's going to be 4 to the 3rd power, which happens to be 64. Okay, so g of 3 is 64. So f of g of 3, look, g of 3 is the same as 64. So I could replace this g of 3 with 64, and it becomes f of 64. What does f of 64 mean? It means I go to the function f, wherever I see an x, I replace it with 64. So it's log base 2 of x, which is 64. Now, what does that mean? That means 2 to what power gives you 64? Well, 2 to the 5th is 32. This is double 32, so it's 2 to the 6th power, so it would be 6 would be the answer there. That's part A. Okay. Part B, right here. Remember, you start with the inside. Forget the G now. Start with f of 1/2. What does that mean? That means I go to the function f, wherever I see an x, I replace it with 1/2. Log base 2 of 1/2. Now, what does log base 2 of 1/2 mean? It means 2 raised to what power gives you 1/2 for an answer. Well, notice it's 2 to the 1st power downstairs, so it's just -1. F of 1/2 is -1 right here. So I could replace this f of 1/2 with -1, and this becomes g of -1. What does that mean? That means I go to the function g, wherever I see an x, I replace it with -1. So it's going to be 4 to the -1 power, which is 4 to the 1st downstairs. Can't run around topless, so 1/4 is the answer. That's how to do those. Okay. This one, we did a problem kind of like this a couple of videos ago. So here's how this one works. Remember, this is logarithmic equation. Log base 3 of blah equals 1. Remember, it was like that. So now convert this base to this power equals blah. I hate that color. Ugh. Okay, and then that's 3. I'm going to switch these around. 3 equals this guy is just like saying this guy equals 3. It's just, I like it with the log over there better. Now I'm going to convert this base to this power equals this. 4 to the 3rd equals x. That's 64. 64 is x, so the answer is 64. And yeah, that makes that positive, so it's a good solution. So that's up through 46 on yesterday's homework. Got a few more to do. So let me just erase these and we can get to those few more. I think this video is going to be, I'm going to spend longer going over this homework from last night than I am covering the new material, because the new material is not going to take that long and it's not that difficult. I think you'll find it not too bad. Okay. Anyways, let's go now, trucking away. Okay, here we go. This is number 47. Log base 6 of x plus 1 plus log base 6 of x equals 1. Okay. So clearly squeeze these guys together. So we're going to get log base 6 of x plus 1 times x equals 1. So I squeezed them together, okay? So now convert, okay? So convert this base 6 to this power, first power, equals this guy, x plus 1 times x. That's just a straight up conversion from logarithmic form into exponential form. Now, 6 equals x squared plus x. Okay, it's a second degree equation. So now I want a minus 6 from both sides. 0 equals, hopefully it'll factor. If it doesn't factor, I can always solve it by a quadratic formula, or completing a square if you'd rather do that. Let's see, x, two things that multiply to be 6 and subtract to be 1 would be 3 and 2. Different signs, bigger ones plus, this is minus. X is -3 and regular 2. Those are my potential solutions. Let's see, does -3 work? -3 plus 1 gives me -2. That makes this argument negative, so it is bogus. Okay, it's an extraneous solution. Okay, number 2, 2 plus 1 is 3, 2, so yeah, it's good, 2 is a good solution, so there you go. It's 47. Let's see what we got here. 50. Here's 50. 2 log base 3 of x minus log base 3 of x minus 2 equals 2. Okay. So, in order to combine this stuff together, I first of all have to pump up this exponent using the third law of logarithms. Log base 3 of x squared minus log base 3 of x minus 2 equals 2. Okay, squeeze those guys together. Now it's subtraction, so I'm going to make it into division. X squared divided by x minus 2 equals 2. Now, I squeezed everything together. I'm looking here. This is one of those logarithmic equations that has log only on one side. So what do? Convert or eat dirt. I think I'll convert. Okay, this base to this power, 3 to the second power, is x squared over x minus 2. Okay, this is 9. I don't like my x minus 2 downstairs. So what I'm going to do is I'm going to times by x minus 2, which will cancel that. But that means I have to times this also by x minus 2. So x minus 2 times 9. Remember, this is just 9. So we've got 9 times x is 9x. 9 times 2 is 18. 9x minus 18 equals x squared, because those guys cancel. So now I want this side to be 0, because this already has a positive in front of the square term. So I'm minusing 9x, adding 18. I get 0 is x squared minus 9x plus 18. Let's hope it factors. But if it doesn't, don't worry, I can do the quadratic formula. Let's see, x. Two things that multiply to be 18 and add to be 9, like say 6 and 3. Same sign, both negative. Yep, negative. So x is 6 and 3. Oh, they're both positive. Then they must be, if they're both positive, they must both be good solutions. No, not necessarily. They might be, but just because they're both positive doesn't mean they're both good. Let's see. 6 is good there. 6 minus 2 is 4. That's good there, so it is good. How about 3? 3 is good there. 3 minus 2 is 1, which is still positive, so guess what? They are both good. We were right. Okay. Let's see what we got next. 51. Holy moly, 51. We're getting there, you guys. Hang in there. Okay, 51 says log base b of x minus 1 plus log base b of x plus 2 equals log base b of 8 minus 2x. Wow, that's a long problem. Okay, so here we go. Now, squeeze the stuff together. Look, it's a plus, so I can squeeze those guys together. But it's log base b, Mr. Ferrari. How do I deal with log base b? You don't have to deal with a log base b because we're going to throw the bases away, or throw the logs away. So don't worry that it's base b instead of some other actual number. Because look, log base b of this is the same as log base b of this. We can drop the logs, and beauty happens. X minus 1 times x plus 2 equals 8 minus 2x. There we go. Now, obviously, FOIL this out. So we're going to get x squared plus 2x minus 1x is plus 1x minus 2. That's what that guy FOILs out to be. 8 minus 2x. Okay, my square term's over here. It's positive in front of it. So I want to wipe out this side. I want this side to be the 0. So I'm going to minus 8 from both sides, and I'm going to add 2x to both sides. Sure enough, that makes that 0 and that 0. And it gives me x squared plus 3x minus 10 equals 0. And I'm going to hope that that thing factors. If it does, I'm in luck. Let's see. X. Can I find two things that multiply to be 10 and subtract to be 3? I know. 5 and 2. Different signs, bigger one, plus. This must be plus, this must be minus. So x is negative 5 and 2, which again are my potential solutions. Okay? So, negative 5 minus 1. Hey, that makes that negative right off the bat. I don't even have to try any others. I know this one is bogus. Okay, how about 2? 2 minus 1 is 1, so that's good. 2 plus 2 is 4, that one's good. 8 minus 2 times 2 is 8 minus 4, that's 4, that's good also. So 2 is a good solution, so there's the answer. The answer, yeah, because that one's bogus, so that one, just one answer. How about that? Okay, I think there might be one more, maybe not. Nope. We're into today's stuff now. So that was it for yesterday's stuff. Today we're going to do applications of logarithms. What we're really going to be doing today is, let me get to the next screen, using a calculator to find logarithms. So we're doing a calculator. Let me grab one other calculator. Actually, got a variety of calculators here. Okay, here's a variety. This is called a TI-83, nice graphing calculator. This is I don't know what it's called. It's just your basic scientific calculator, right? Casio, whatever. And this is called a smartphone, okay? So we'll get into all those. They all are calculators. Probably, I don't know. They used to say this was like the brightest one of them all. This was like the TI-83, TI-84. Those guys were like back in its day, back when I was your age, this thing was like king, right? Nowadays, I think this guy might be king because believe it or not, the smartphone will do more than a lot of stuff, more than the computers that shot the people to the moon and everything. So we used to say that about this one. Now this one's probably even more than like whatever. I don't know. Okay, here we go. Okay. Well, anyways, here's how it works. So let's just start doing it. You'll see it's very simple. First of all, the traditional calculator has a couple of buttons. Like for instance, this one right here, there is a log button right there. It says log. I don't know if you can see it right there, but it's fine. It's like, well, actually it's like up here. I have it up there. So there's a log button here. And this one also has a log button. It's right here. It's the 1, 2, 3, 4, 5, 6th button from the top. It just says log on it. Both of these calculators, both of the old-fashioned calculators are like there. See, traditional, log. That's what your log button looks like, okay? The smartphone has the same button. Now, here's the thing. If you have a smartphone and you look at, your calculator looks like this, that's not good. That does plus, times, minus, divided by, all that stuff. But if you do this, it turns into a magic, awesome calculator here. And so it has all these other functions that it opens up, okay? So in particular, there's a log base 10 button there. See, it says log base 10.
Wait.
Can you see that?
I'm trying to make sure. Okay, it's in focus now.
Log base 10 right there, okay? In fact, when we get to, just for now, since we have it focused in, this log base 10 button on a calculator can actually turn into log base Y, which means you could do any base, right? If you hit that second function key, there's a second function key. See, when I hit the second function key, this turns into log base over here, log base Y. So anyways, it's like, that's just a little factoid for you on smartphones. I think most of them are that way. Maybe there might be some smartphones that aren't exactly like this. I don't know. I just know how mine works, okay? But make sure, notice when you hit the second function, it stays on. So if you start doing it, if you just mean to hit the second function to do one calculation and want to go back to the others, you need to hit it and to turn it off again. But anyways, there is, when you take the second function off, there is one that says log base 10. That is what we're talking about, okay? So that button means log base 10. That button means log base 10. If you just see log without a base, it doesn't mean there's no base. It means the base is 10. Just like if we are at a square root and you don't put the little 2 there, everyone knows that a square root means square root if you don't put a number there. Same thing with logs. If it just says log, it means log base 10. Every log has to have a base. So it means base 10 if you see that. Okay, that's the first thing. Then, let's get over to this. So, this is what I just showed you also. Some smartphone calculators also have a log base Y button. Usually you have to press the second function key to access it, just like I just showed you, right? So you hit the second function key, then you'll see the log Y. So if you wanted to find log base 7 of 49, first of all, let me tell you what, these calculators will not do log base 7 of 49. You have to use what's called the change of base formula, which you guys will see, in order to make these guys figure out log base 7 of 49, right? You can't do that. But if you have one of those calculators or a smartphone calculator that has a log base Y button where you can do any base, then you can do that. To do log base 749, you type in the 49 first, then you hit your log base Y button, then you put in the base of 7 equals, and it should spit out 2. You know what? Here's a tip I'm going to give you for when you're doing calculator stuff. If you're wanting to find out how you type it into your calculator, because sometimes if you type the 49 in, then you type the 7 so that it would give you the 2. But other calculators might require you to put the 7 in first and then the 49 to give you 2. So how do I tell you to figure it out? The way you figure out how your calculator works is you always put in something you know the answer to. For instance, I know log base 7 of 49 is 2 because 7 squared is 49. So if I'm trying to find out what order I type stuff in order to make my calculator spit out the right answer, I'm going to plug in something that I know what the right answer that I'm expecting is going to be, so that I can figure out exactly how my calculator does it. Because different calculators are different. You may or may not plug it in the same way I'm plugging stuff into the calculator. Your calculator may require you to do it differently. So the best way you can figure out how your calculator actually works is to put in some problems that you know what the answer is supposed to be, and then you can figure it out. Okay, moving on. So, there's also the x to the y power. I didn't mention that yet. There's x to the y or y to the x key. That allows you to raise any base to any power, okay? So, if you wanted to do 5 to the 3rd power, you'd hit 5, and then your x to the y or your y to the x key, and then 3 equals. Now, if that gives you 125, because we know that 5 to the 3rd is 125, then good for you. If it doesn't give you 125, then say, wait a minute, maybe I hit mine the other way around. So I would hit 3 first, then I'd hit that button, then I'd hit 5, and see if that gives me 125. If that worked, then I would know, oh, I have to put the power in first and then the base. So it just figure out how your calculator works so that you know how to do that. But that's a very powerful key, the x to the y key or the y to the x key. So I would say if you're not sure how to access it on your calculator, I would help you, but we aren't really contacting each other. If you really can't figure it out, maybe you can email me a picture of your calculator and I can try to tell you how to do it. So anyways, we can try that.
YouTube tutorials, I'm sure they have tutorials on it too.
YouTube tutorials on it. That's a good idea. That's a good idea as well. Okay, so anyways, that's the deal. So that's the background information. Now we're going to start using this stuff. So here's the deal. These are 3 different problems. Okay, I'm going to work them all at once. Now, on this calculator right here, to do log 3.8, this calculator, you have to TI-83. You have to put in the log first. I have to hit, if I hit 3.8 log, it's going to give me an error, okay? In this one, I have to hit the log button, then I hit 3.8 enter, and it says 0.57978, so on, so on. Now, this particular calculator, I have to put the number in first, the 3.8 in first before I hit the log button. So if I hit 3.8, and then I hit log, it gives me 0.579783596, just like it's supposed to be, right? And the smartphone calculator is the same way. On the smartphone calculator, you need to put the 3.8 in first. So 3.8, then you hit the log base 10 button, 0.5797883, so on, so on. So, and they want it rounded to 3 significant digits, I believe it is, or is it 4? 4 significant digits. So this one is 0.5798. I got 0.57978. So the 8 bumps the 7 up to an 8 and rounds to that. Okay. So log 97,500. You just go 97,500 and hit log button. And it gives me 4.989, so on, so on. This one, I would have to hit log and then 97,500. It would still give me the same answer. And this one, I would have to hit 97,500 and hit the log button. Either way, it should give you that number, 4.989, if you round it off. Then finally, 0.000542, I would put that in, 0.000542, hit the log button, and it gives me negative 3.266. Remember, logs can be negative, and that's a small number, 0.000542. So yeah, you would have to raise 10 to some negative exponent to get that, and it turns out to be negative 3.266. So it's right there, see? Okay, so just type it in. You type it into your calculator. Those are the numbers that your calculator should be spitting out when you're finding those things. That's how you know that you're typing it into your calculator correctly. Okay, let's go to the next thing. Log x equals this. Now remember, there's a little 10 down there. Okay, so if I convert it, log base x equals 0.8995. Well, look, if it's base 10, that's just saying 10 to the 0.8995 power equals x. So I just have to raise 10 to that power, the 0.8995 power. Well, on this smartphone right here, there is a 10 to the x key right above the log base 10 key, okay? Well, they can see it there. It's right above there. It just says 10 to the x. This guy right here, the second function key of the log is 10 to the x. So this one you have to hit shift and then the log key, which makes it 10 to the x power. And this guy here also has a shift, so you'd hit second function log key, which makes it 10 to the x. So for this one, you have to put the 10 to the x in first, though, on this one. On the other two ones, you put the number in first. So if you're doing it on a TI-83, you would say second function log, which gives 10 to the x. It says 10 raised to the power there, 0.8995, close parenthesis, equals 7.934, so on, so on, so on. Okay? Let's see if that's right. Is that what it should be? 7.934, so on, so on, so on, right? Okay, how would I do it on this guy or this guy? I would have to put the 0.8995, then hit my 10 to the x key, or for this guy, hit shift log, which makes it 10 to the x, equals, 10 to the x key, 7.93414, so on, so on. Now, it says find it to 3 significant digits. So it rounds off to 7.93. See the 4. If this number's 4 or smaller, this number stays the same. If this number 4, if this were 5 or bigger, that would bump that up to a 4 and make it 7.94. But it's not, so it's 7.93. Okay, how about this next one over here? Well, it's going to be, look, 10 raised to the 2.4825 power. So I'm going to do 2.4825, 10 to the x. That's 303.738, so on, so on. Right there, 303.738, so on, right? To 3 significant digits. Now look, this 3, 1, 2, 3, there's my third significant digit. The one next to it is 7, which is 5 or bigger, so it bumps this up to a 4. So to 3 significant digits, this is 304. Now, the 10 to the x key, that's just about showing you how 10 to the x key works. And for traditional calculators, you have to play the shift or the second or the inverse function. It's usually the inverse of the log key on traditional calculators, okay? On smartphone calculators, it's the button right above the log base 10 key, or at least on my smartphone calculator. Okay. So now we're actually going to solve equations, and we're going to do, notice there's a part A and a part B. Solve for x. A, give the solution in calculation ready form. That means not as a decimal, you just put it, I'll show you what that means in just a minute. And then give the solution to 3 significant digits. That's when you plug it into the calculator. So A is when you give it before you plug it into the calculator. B is your 3 significant digit answer after you plug it into the calculator. So here's how it works. Okay, 5 to the x equals 13. Now I want to point out something. We have not solved an equation like this yet. Now we have solved equations that have variables in the exponent. We have ran into that. We just ran into that recently, but now we know how to do that. But the difference between this problem and all of the ones we've done so far is that the way of solving when you have a variable in the exponent, the way we've been solving is to make them powers of the same base and then throw away the bases and set the powers equal to each other. That was the idea. Make them both powers of whatever, both powers of 5 or both powers of whatever, and then throw away the bases and set the powers equal to each other. That will work if you can make them both powers of the same base. But 5 and 13 are not both powers of the same base. 5 and 25 are, 5 and 125 are, right? That would be nice if it were those numbers, but it's not. It's 5 and 13. Those are not powers of the same base, so we have to do it differently. We can't just make the bases the same and then throw away the bases. So what are we going to do? This is what we're going to do. We're going to use the third law of logarithms by doing this. If 5 to the x is 13, then it would be true that the log, and when I put log, I mean log base 10, because that's what, when you don't write a base, it's 10. Log base 10 of 5 to the x would be the same as log base 10 of 13. If these two are equal, then this would have to be equal. That's a true thing, okay? Now, why would I do that? I just complicated it more than it was. Look, here it was just a nice little equation, right? And now I've complicated it by taking log of each side and made it a more complicated equation. Well, the reason I did that is so I could use the third law of logarithms. What does the third law of logarithms do? Look, this guy's like, help, help, I'm afraid of heights. Get me down from here, get me down from here. Okay, I'll take log of both sides, right? And then I can bring you back to the ground, put the x right there, and then you're safe on the ground. Oh, thank you, Mr. Furry. You're welcome. See? No problem. That takes him from where he's afraid, way up there, afraid of heights, down to the ground. Now, x times log 5 equals log 13. Now, how do I solve this? Here's what you need to understand. Log 5 is a number. It's not log is a thing and 5 is a thing. No, it's log 5 is a number. This is an entire number. So this is just like x times 10 or something like that. Log 5 is just a number. So if you have x times a number equals another number, right? And I want to get x by itself. To get rid of times a number, you just divide by the number. So you just divide by log 5. Like that. And then you get x is, this cancels, right? Log 5's cancel. Log 13 over log 5. Now, as I just said, okay, I just said this, listen, log 13 is a number. It's not log and 13. Log 5 is a number. It's not log and 5. So you cannot say, oh, cancel logs and I get 13 over 5. It doesn't work that way. This is a quantity, this is a quantity. You can't separate the logs from this and cancel them. It doesn't work that way. In fact, part A, give this answer in calculation ready form. This is the answer in calculation ready form. That's as simple as it gets, right? That's part A, okay? Part B, now we want to give it to 3 significant digits. So it just means plug that into the calculator. So here, I'm going to show you how I do that. I'm going to go, actually, okay. Here's how you type it in the calculator. Okay. So first thing, I want to do log 13 divided by log 5. This calculator, I have to put the 13 in first to do log 13. So I hit 13. Then I hit log base 10 or log, and I get 1.11394, okay? Now I'm going to hit divided by, okay? Now I need to do log 5, so I'm going to hit 5 log. Now, be careful. I just hit 5 log and it's pointing, and it's displaying 0.69897. Now 0.69897, you know what that is? That is log 5. I just hit log 5. I hit divided by log 5. So it's displaying log 5 right now. If I wanted to actually perform the division that I just hit, I have to hit equals, and then it will actually do the division. So I hit equals, and I get 1.59369, and so on. So it's about, to 3 significant digits, it's going to be 1.59. And that's how you do it. Now, the nice thing about it is you can check your answer. If you think you did it right, but you're not sure, you can check your answer. You can do 5, then x to the y key, or y to the x to the y right here, x to the y, 1.59, right? Because if that's my answer, if I raise 5 to that power, I should get 13. Do I get 13? No, I don't. You know what I get? 12.922969. 12.9229. What's my calculator trying to say? What's it trying to say? It's trying to say 13! But I rounded off to get that number, so it's not going to spit out exactly 13 because I rounded it off. It's doing its best. It's like, hey man, 12.922, that's 13. I'm trying to say 13, but you rounded it off or whatever. So you won't get exactly that, but you should get darn close. Okay, so it's a good way to check your answer. Okay, let's try another one. 3 to the 8x equals 7. Okay, very, very simple. Oh, let me put the answer here. 12.92. Oh, no, sorry. It's 1.59. Okay, that answer goes here. 1.59. Sorry. Okay, so let's go to this one now. 3 to the 8x equals 7. Again, can't make 3. Now, if I could do that, if I can make 3 and 7 powers of the same base, that's the easiest way to do this problem. But I can't, so I can't do it that way. So what am I going to do? I'm going to take log of both sides. Log of 3 to the 8x equals log 7. Okay. Now, I'm going to pump the 8x out front, right? That's the whole reason I took log, is so I can do this. Help, I'm afraid of heights. Okay, let's get him down. 8x log 3 equals log 7. Now, I have 8 times x times log 3. I don't want 8 times x times log 3. I just want x. So to get rid of 8, I'm going to divide by 8. To get rid of times log 3, I'm going to divide by log 3. So I'm going to divide by 8 log 3. Okay, that cancels that and that. Now I get x is log 7 over 8 log 3. That is actually the answer in what they call calculation ready form, right there. And then let's turn it into a decimal. Okay, so here we go. I'm going to say, okay, log 7 first. I'm going to do 7, hit log 10. Okay, it gives me 0.845098. Okay, then I'm going to hit divided by. Now I want to divide by this quantity. So I'm going to do parenthesis. I'm dividing by a quantity, so parenthesis 8 times, and then I hit 3 log. Now, when I hit 8 times 3 log, it's just showing me log 3 right now. If I wanted to actually times by 8, I have to close that parenthesis, so I'm going to hit close parenthesis. It gives me 3.8169. Now, what is 3.8169? It's just 8 times this. It's this whole quantity. If I wanted to actually do this division, I'm going to have to hit equals again. And it gives me 0.2214. And then the 3 significant digits is 0.221. So x is approximately equal to 0.221. And that would be the answer. Now, what if I'm not sure if I did it right? I'm not sure if I typed that in right. Well, it's nice because you can check it. Look, if I take 0.221 and times it by 8, let's see, I'm going to see what that is. 0.221 times 8 is 1.768, right? So if I raise 3 to that power, so I'm going to use my y to the x key. I'm going to do x to the y, 1.768. So I'm going to do 3 x to the y, 1.768. I get 6.975. which is pretty much 7. So there we go. So I did do it correctly. All right. If you do it on here, this kind of a calculator, then here's what you would do. You would do, first of all, you would do log, and then 7, like this. And I would hit enter, okay? That gives you 0.845, whatever. That's just the top log 7 right here. Now, if you want to divide by 8 log 3, you could go divided by, and then you could do 8, a parenthesis, I did parenthesis first, parenthesis, then 8 times, then hit log 3. Now, log throws in an automatic parenthesis, so when you close parenthesis, you're going to be closing the 3 for log 3, so you need to hit another close parenthesis to meet up, to handle the parenthesis you put in before 8, and if you do that, equals, you get the answer. Oh wait, I did minus instead of divided by. Let me try that again. Okay, I'm going to do log 7, okay, divided by parenthesis 8 times log 3 is log 3, close parenthesis, boom, and you get 0.221. That's what I got. Okay, anyway, that's how that works. Okay, let's do another one. Here we go. I believe this is the last one, if I remember right, so hang in there. 6 to the negative 2x equals 3. So again, well, 6 and 3, no, you can't make those powers of the same base. They're multiples of 3, but they're not powers of 3. So you can't do that. It was nice to think of that for a second, but it doesn't work that way. So here we go. So what am I going to do? I'm going to take log of both sides. I'll show you one other thing after this, but let me go ahead and take log of both sides. Negative 2x equals log 3, like that. Then I can move the negative 2x out front. And I get negative 2x log 6 equals log 3. Okay. So I want x by itself. So first of all, to get rid of negative, I divide by negative, right? To get rid of times 2, I divide by 2. To get rid of times log 6, I divide by log 6. So I divide by negative 2 log 6. Okay. Now, good news over here. This cancels, this cancels, this cancels. I get x equals, I like putting my negative out front. Negative log 3 over 2 log 6, right? So there you go. That's the answer in calculation ready form. Notice, to not cancel the logs, cannot cancel the 3 and the 6 and make it like a 1 and a 2. That doesn't work that way. It's log 3 and log 6. You can't cancel these arguments inside the logarithms like this. But one thing you could do at this point, if you're wanting to put it into the calculation ready form, or it is calculation ready form, if you want to plug it into the calculator, here's what I would do. Notice something here. See this 2 right here? This could pump up and be log 6 squared, which is 36. So this is really the same thing as negative log 3 over log 36. I could turn 2 log 6 into log 36. That's going to be a little bit easier to plug into the calculator, because now I just do log 3 divided by log 36. I'll do it on this one. So here we go. I'm going to do log 3 divided by 36 log I hit, and then I have to equals 0.30657, so about 0.307. So 0.307 is what it is as a decimal. All right, so that's kind of how that works. Oh, one last problem, this kind. I'm pointing this out because we've already done these. We've been doing these quite a bit lately. Look at this problem here. I'm going to go ahead and work it out because I want to refresh your memory. Oh, dang it. I was going to show you one other thing. Let me show you one thing before I do that, but I keep forgetting to show you. This is 13. One thing you could have done, you might be thinking about this, and there is another way to do this if you do have a smartphone. Because in the old days, before smartphones came around, and they didn't have this button, log base y, they didn't have that button where you can just do any logs. Because back in the day, back when I was your age, we didn't have a log base y button. We only had log base 10 buttons. So anyways, that was a long time ago. So what you could do, since you do have a log base y button, you could actually do this. You could convert this guy. Let's convert right now. It would be log base 5 of the answer 13 equals x. And then you would just have to figure log base 5 of 13. That would work. It would still give you 1.59 if you did that on your calculator and you plugged it in the right way, okay? But, so you could do that. We didn't used to be able to do that. So I wanted to show you guys this way because not everybody's gonna have the type of calculator that will do a log base y. If you have a log base y here, let me just show you what you would do here with the log base y button. You would say, first of all, let's convert. So it's gonna be log base 6 of 3 equals negative 2x. Look, log base 6 of 3 equals negative 2x is the exponent. Okay, hold on. And then divide by negative 2, divide by negative 2. So if I had a log base y button, I could just do log base 6 of 3, get that number, divide by negative 2, and that would end up being my x.
What important formula can they get from the first problem? There's a formula.
We're going to get to that.
Oh, okay.
We'll get to that.
Okay.
Yeah, that's next time, actually.
Okay. Never mind. Stay tuned.
Yeah. That's next time. Okay. This one though. I'm doing this one. Sorry, I'm doing this one. Okay, 25 to the x. Now, you should already know how to do it. I'm just refreshing your memory on this. Because this, I'm so fortunate that this is, remember I told you that the easiest way to do problems that have variables in the exponents are if you can make them powers of the same base, right? We couldn't make these powers of the same base. That's why we had to do it this way, okay? But in this case, you can make them powers of the same base. Look, this is 5 squared to the x, which is 5 to the 2x. This is 5 to the 1 times 5 to the 1/3, right? That's 5 to the 3/3 plus 1/3 is 4/3. 5 to the 2x is 5 to the 4/3. Now, 5 to this power is the same as 5 to this power, so you could throw away the bases. 2x. We just did a bunch of them like this the last few videos, so I'm just trying to refresh your memory because there's a few of these in the homework. They say solve these problems without using logarithms, and what they're getting at is this. Okay. Then, since this is a fraction over here, to get rid of times 2, I would times by the reciprocal, and I'm going to get x equals, look, 4 over 6, which actually is 2/3, right? So x is 2/3. So there you go. That's going to get you through. You're just most of this homework assignment is going to be just plugging stuff into the calculator. A little bit of solving some equations though. There it is. There's homework number 41. Page 481, oral exercises 1 through 10 all, and 13 through 16 all. And page 481 to 482, written exercises 9 to 25 odds. Cool.